Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video, we will discuss question number 40, NEET Physics paper 2016. Hello students, today we will discuss question number 40. A NPN transistor is connected in common emitter, this should be emitter, common emitter configuration in a given amplifier. So common emitter configuration in a given amplifier. A load resistance of 800 ohm is connected in the collector circuit and a voltage drop across it is this one. That means, okay, this what if the current amplification factor is 0.96, that means alpha is 0.96 and the input resistance is this one, input resistance 192. So input resistance of the circuit is 192 ohm. The voltage gain and the power gain of the amplifier will be, so what is required is the voltage gain and the power gain. Okay, voltage gain and power gain of the amplifier. Now this is just a rough idea I'm giving you, that this is the transistor NPN and this is should be emitter because this is common to both the input circuit and output circuit. So this is the base, this is the collector, base, emitter, and here the direction of the current flow will be in this sense between an emitter base junction. So this is how is the circuit looks like. Now we have current here. This is the output circuit. The load resistance will be here. The load resistance somewhere will be here. That is not drawn. The output resistance, the load resistance is this one, which is 800 ohm. 800 ohm. The input resistance will be somewhere here. That is 192 ohm input resistance. This is the input circuit, this is the output circuit, this is the common emitter configuration. The amplifier and the rest of the circuit is not shown because the circuit is not required. The input signal that we feed here is amplified over here, and we are interested in this voltage gain and power gain. Now in this situation, common emitter configuration, we have to find beta. What is beta? Because for common emitter configuration NPN junction transistor, beta equals to alpha divided by 1 minus alpha. So for common emitter configuration, we'll find the voltage gain, then alpha divided by 1 minus alpha, which comes out to be 0.96 because that is alpha, divided by 1 minus 0.96, which is 0.96 divided by 0.04. This is 96 divided by 4, so that is equal to 24. So beta comes out to be 24. After we get beta, we know that voltage gain in common emitter configuration. Voltage gain in common emitter configuration, it is AV is beta times output by input resistance. Voltage gain in common emitter. This beta we got as 24 now. Output resistance is load resistance is 800. Input resistance is 192. You can see here input resistance is 192, output resistance is 800. Now if we solve this, how much we'll get? Then where to solve? This is 8 to the 16, 32, 8 for the, so here if I write this one, then if I cut in 8, then this is 100. If I cut in 8, then it is 8 to the 16, 3 to the 4. So this and this will cancel, and we are left with 100. So the voltage amplification value, the voltage gain is 100. The voltage gain is 100 in common emitter. So there is no 100 here. There is no voltage gain here. The voltage gain is not 100. No one is having 100. So that means he is not asking about the common emitter. Again, let us find the power gain. This is all we are doing for common emitter configuration. Power gain equals to, in common emitter configuration, is PV equals to beta times the voltage gain, beta times the voltage gain, and the beta is 24, voltage gain we got 100, so it is 2400. This is the power gain, which is also not there. So we'll find the for common base configuration. For common base configuration, CV mode, the voltage gain will first write. The voltage gain AV equals to the alpha times common base. We are using alpha times load resistance by internal input resistance. This alpha we got 0.96 already given in the question, because that is you can see that alpha is 0.96, output is this, input is this. Just you have to put the values. 800 divided by 192. So this is 24, that already got last time. This is 24, and this is 24 for the 96. So this is 0.96 into, so here 24 is here actually, this will be 24. So eight is 24 is 100 is there. Okay, I'll put 100 here, 100 here, 24 here. That is okay, because 8, 24, 100 is there. So this is 0.96 into 100 divided by 24, which is 4, because this is 4 times this, and this is 0.04 into 100 is 4. So this is the voltage gain, this is 4. If I see that, then I get the option. That means the question is writing about common emitter, but the answer is for the common base. This voltage gain is 4. 4 is in all options, so this is not correct. These are out of 3 you have to find. Voltage gain is 4, so 4 is there. Now after 4 we have to find the power gain. So let us find the power gain. The power gain in common base configuration, the power gain in common base configuration, that is power gain in this, equals to the alpha times the voltage gain. Alpha is 0.96 into voltage gain we got now as 4. If I multiply 2 6 24, 4 to carry 38, 3.84. So voltage gain I am getting 4, the power gain I am getting 3.84. This answer is only for common base mode. So you can see that 4 and 3.84, 4 3.84, so therefore the option number 2 is correct. But we have got this for the common base configuration, not for common emitter configuration. Okay, thank you.